Imagine observing a honeycomb and discover that every single cell follows the same exact pattern. Now, look at the humanity's most advanced telescope and discover that it follows the same exact pattern. And that's not coincidence, it's mathematics expressing efficiency in different scales of life. Today, we're going to talk about how bees use math to become the most efficient as possible.
Well, honeybees must construct thousands of storage cells for honey, pollen, and larvae. Yet, wax production is metabolically expensive. A colony uses approximately 8 kilograms of honey to produce only 1 kilogram of wax. As a result, every geometric decision influences survival. So, one of the first scholars to take an interest in the geometric structures built by bees and the nature of the honeycombs was the Greek Pappus of Alexandria. In his essay, he suggested that a repetitive hexagonal pattern visible when cutting a cross-section of a honeycomb was the architecture solution that used the least amount of wax possible to construct its partitions. This hypothesis became known as the honeycomb conjecture. So, to demonstrate the validity of this conjecture in a straightforward manner, we sought to find a two-dimensional geometric shape that could be repeatedly indefinitely to cover a flat area, such that the total length of the cell perimeter was short as possible for a given area. And it was shown that it's only possible to fill the plane with the same rectangular polygon without leaving any gaps, using equilateral triangles, square, and regular hexagons. So, bees could use any of these three shapes, but even worker bees dislike doing necessary work. So, which of these three options would have the smallest perimeter, thereby using the least amount of wax? Now, let's suppose there are three shapes and a perimeter of 12 centimeters. The area of the equilateral triangle would be approximately 6.93 cubic centimeters. The area of the square would be 9 cubic centimeters, and the area of the hexagon would be an incredible 10.39 cubic centimeters. Therefore, the hexagon is 14% more efficient than the square and 43% more efficient than the triangle. In other words, a beehive that produces 15 kilos of honey using hexagons would produce only 10 kilos of honey using triangles. And in nature, that is the difference between life and death. So, let's imagine the same problem but in cosmic proportions. NASA wanted to build the James Webb Space Telescope, the most advanced telescope ever created. Its mission was to look back to the very beginning of time and catch the faint of the light of the first galaxy formed after the Big Bang. To do this, the telescope needed a massive mirror, but engineers faced a major problem. A larger mirror collects more light, but it's also become too heavy and too big to fit inside a rocket. NASA needed a design that could maximize light collection while minimizing weight and size. The breakthrough came from a brilliant idea. Instead of making one giant mirror, they built a mosaic of 18 separate smaller mirrors. Each segment was shaped like a hexagon and coated with this layer of gold. When the telescope reached space, these pieces unfolded to act as a simple giant mirror, about 6.5 meters wide. Choosing an hexagon was not an accident. This specific shape solved several problems at once. First, hexagons fit together perfectly without leaving any empty gaps, which creates a smooth surface for sharp images. And second, when you group hexagons together, they form a shape that is very close to a circle, which is perfect shape for focusing light. Third, hexagons distribute weight and pressure evenly, making the structure incredibly stable. And finally, this shape allowed the mirror to fold up like an origami during launch and then fold safely out in space. Science is launched in 2021. This design was allowed in the telescope to travel 1.5 million kilometers away and send back a breathtaking picture of distant planets and ancient stars. Remarkably, NASA genius design was nearly new. In 1999, a mathematician named Thomas Hales proved the famous concept called the honeycomb conjecture. His math proved exactly what bees have known for millions of years. A pattern of hexagons is the most efficient way to divide a surface into equal space, using the least amount of material. Bees use hexagons to save wax and store the most honey possible. NASA uses hexagons to save weight and catch the most light possible. This same shape appears all over the world whenever nature needs to find the most efficient solution to a problem. You can find hexagons in delicate shapes of snowflakes, the strong atomic of structure of crystals, and even volcanic rock formation. From a simple beehive on Earth to a high-tech telescope exploring the edge of the universe, the exact same geometry rule shows up again and again. Nature and human technology arrive at the same answer because they are solving the same puzzles. The story of this space telescope reminds us that mathematics is much more than just a school, subject, or a human invention. It's a universal language that connects living creatures, nature owners, and our journey to the stars.